All right, so today, lesson 8-7, multiplying and dividing square roots. The big idea is, like powers, square roots distribute over products and quotients. The big thing I want you to remember when dealing with these square roots is the fact that in order to multiply these square roots together, they have to have the same index. Okay? On a square root, the index is actually a 2. They just don't ever write it because something times something equals the number that is right inside here. Okay? So if this was the square root of 2 times the square root of 2, that's going to give me the square root of 2 times 2, which is 4, which we obviously know the square root of 4 is 2. Likewise, when we're dividing, okay, the indexes have to be the same. In this case, I'm going to use a cubed root. So, the cubed root of 16 divided by the cubed root of 2 is equal to, and since these are cubed roots, you're going to get out a cubed root. 16 divided by 2 is 8. Well, what's the cubed root of 8? Something times itself 3 times. That's going to give me 8. And you would say is 2. Okay? So the big important thing I need you to know is the indexes have to be the same, whether it's the 4th root, the 5th root, so on and so forth. They have to be the same. So, product of the square roots property. Obviously, we're just talking about square roots here. You can use it for cubed roots, 4th roots, 5th roots, etc., etc. But it says for all non-negative real numbers, so we're dealing with positive numbers, A and B, the square root of A times the square root of B is equal to the square root of A times B. So for an example, the square root of 5 times the square root of 3 is equal to the square root of 15. Okay? If these have the same indexes, you can go ahead and multiply these two numbers together. The quotient of the square roots property. For all positive real numbers, A and C, the square root of C divided by the square root of A equals the square root of C over A. So in essence, the square root of 1 all over the square root of 4 is equal to the square root of 1 over 4. Okay? And those are two properties that you need to remember. Let's look at Quiz Yourself 1. Use either the product or the quotient of square roots property to evaluate each expression. Here I'm going to use my product of square roots because I am multiplying. So the square root of 8 times the square root of 2 is going to give me the square root of 16, which we all know is plus or minus 4. Okay. The square root of 45 divided by the square root of 5 gives me the square root of 45 divided by 5. Well, what is 45 divided by 5? You're going to tell me is the square root of 9. What is the square root of 9? Plus or minus 3. Okay. C, we're dividing. Okay. Square root of 80 divided by the square root of 40 gives me the square root of 80 divided by 40. What is 80 divided by 40? You're going to tell me is 2. Now, this is our exact answer. Could we do square root of 2 on our calculator? Sure. If I pull out my calculator here, Square root of 2 is 1.41 if I round it, so we could say plus or minus 1.41. Okay? Exact answer, this is our approximate answer. Please remember that from previous lessons. Exact answer and approximate answer. Now, where does the product of square and roots come into handy? Simplifying radicals. A radical expression is said to be simplified if the quantity under the radical sign, called the radicand, okay, this number is called the radicand, 40, has no perfect square factors other than 1. Just as you can multiply square roots by using the product of the square roots property, square root of 4 times the square root of 10 is equal to the square root of 4 times 10, which is equal to the square root of 40. You can rewrite a square root as a product by factoring the radicand. So this is what Mr. Johnson calls the good box and the bad box. When he has the square root of 40, he thinks about this. What are my factors of 40? Well, you're going to say 2 and 20, 4 and 10, and 1 and 40. Then he asks himself, which one of these numbers has a square root? Well, the 4 has a square root. So, the square root of 4 goes into the good box. The square root of 10 goes into the bad box, because I can find the square root of 4. I cannot find the square root of 10. Okay? Notice how 4 times 10 still gives me 40. So when you break up 40, it doesn't really change anything. It's just that I'm going to simplify it a little bit further. Now, how do we go a little bit further? Well, since we can find the square root of 4, the square root of 4 is 2. And then what you need to do is you need to just bring the bad box with you. So, even though the square root of 40 is our exact answer, to simplify this answer down, we would call it 2 square root of 10. Okay? Many people consider 2 square root of 10 to be simpler than square root of 40 because it has a smaller radicand. This process is called simplifying a radical. The key to this process is to find a perfect square factor of the radicand, as we did right here. And the most important thing is to find the biggest square factor of the radicand. Okay? Sometimes if you end up with a smaller of the square factors, you're going to have to end up doing it again. Okay? So, as I said before, Mr. Johnson calls this the good box and the bad box. You're going to hear him say that numerous times. Good box is what you can find the square root of. Bad box is what you can't. Let's look at example 1. Okay? Simplify the square root of 27. 27 doesn't have a whole lot of factors. 1 and 27 and 3 and 9. Well, something should jump out at you. The simple fact is that 9 does have a square root. So I'm going to break 27 into the square root of 9 and the square root of 3. You all are yelling at me, well, this is the good box, this is the bad box. Good box, bad box. I can find the square root of 9, I can find the square root of 3. The square root of 9, everybody is saying, is 3. I bring my bad box along with me, and the square root of 27 can be simplified to 3 square root of 3. Let's look at example 2. Each leg of the right triangle below is 7 centimeters long. Okay, as you can see here, 7 centimeters, 7 centimeters. Each leg. The legs are opposite of whatever the hypotenuse is. The hypotenuse is found at the opposite of the 90-degree angle. So, which means these two angles have to be 45 degrees, remember, because all these have to add up to 180, and if these sides are the same, these angles have to be the same. It says find the exact length of the hypotenuse. So I'm going to use the Pythagorean theorem. So what's my length of my hypotenuse? My length of my hypotenuse is c, so we're going to call it c squared. Okay, equals, I'm going to call this a, I'm going to call this b. It doesn't matter. Okay, if you remember, 7 squared plus 7 squared, c squared equals 49 plus 49. C squared is equal to, everybody should be able to do this in their head, is 98. We just want C, so I take the square root of this. C is equal to the square root of 98. Now, this would be our exact answer. Okay? This is A. Find the exact length of the hypotenuse. The square root of 98 is our exact answer. If we want an approximate answer, we would just go to our calculator and get a decimal, right? Out to like 2 places. B says put the exact length in simplified radical form. So I'm going to take square root of 98 and put it in the good box and the bad box. Okay? Well, if you kind of notice up above here, some factors in 98. 2 goes into 98 49 times. Obviously 1 in 98. Does 4 go into 98? Not evenly. Okay. Does 12 go into 98? Once again, not evenly. And what I mean by that is, if I type this in my calculator, if I take 98 divided by 12, obviously I got out an 8.16 repeating. Obviously it didn't go in there evenly. If I take 98 divided by 2, okay, obviously it went in there evenly because it says 49 times, which should jump out to you that we can find the square root of 49. Square root of 49 is 7. So this breaks up into the square root of 49 and the square root of 2. What is the square root of 49? Square root of 49 is 7. Bring along my bad box. 7 square root of 2 is the square root of 98 simplified radical form. And there's your answer to B. Example 3, assume x and y are positive. Simplify the square root of 48 x squared y squared. Now, you treat the number just like you did before. Okay? Treat the number just like you did before. Factors of 48, 2 and 24, 1 and 48, 4 and 12. Anybody got anything else? 16 and 3. 6 go in there. 6 should go in there, shouldn't it? As you can see, I did 48 divided by 6. It gave me 8. Eight and 6. So now I need to go through it here, and I need to see which ones have a square root. Can I find the square root of 24? Not evenly. Those are done. Square root of 48? No. If I could, I wouldn't be in this predicament. 4 and 12. Okay, 4 is a good one. Okay. 16 and 3. I'm going to use 16 because that has a bigger square root than 4 does. Okay. If I left it as 4 and 12, I'd have to go another step further, and I don't want to do that. It just creates me more work. So I want the bigger number, so I'm going to use 16 and 3. So in my good box, I'm going to put 16. In my bad box, I'm going to put 3. Now, here's a note that you need to make. Dealing with variables, you put the number of variables in the good box that are divisible by your index. Now remember, my index is this number right here. And in this case, it's invisible, so it's the number 2. So my index in this case is 2. Okay? So, I have 2 x's here. Is 2 divisible by 2? Yeah. So, I'm going to put all of my x's in the good. There is none left to put in the bad. Okay, so I don't put anything in there. I have 2 y's. Is that divisible by 2? Yes, so I put all my y's in the good. Now, if there was 3, I'd put 2 in here. I'd put 1 y in here because 2 plus 1 y would give me 3 y's. Okay? But in this case, we only have 2 y's, so I put my 2 right here. I don't put any over here. Now, same thing with your taking the square roots. We know the square root of c squared gives me c. So what's the square root of 16? Square root of 16 is 4. The square root of x squared is x. The square root of y squared is y. And then you still have to bring down your bad box, which gives me the square root of 3. So simplifying for the square root of 48 x squared y squared gives me 4xy square root of 3. Let's look at quiz yourself 2. Assume x and y are positive. Simplify the square root of 25 x squared y. Good box, bad box. Can I find the square root of 25? Yeah. So I put 25 in the good. My index is 2. So I have an x squared. So I'm going to put all of them in my good. I only have 1 y. So that goes in my bad box. Notice if I multiply these two things together, 25x squared times y, excuse me, gives me 25x squared y. So you need to make sure that when you multiply these two things together, you still get out what you started with. Okay? So what's the square root of 25? 5. What's the square root of x squared? X. And bring my bad box with me. B, assume x is positive. Simplify. Here's a quotient property. So what I can do is end up putting these together and just reducing them down, right? Well, this turns into, actually, if I wanted to do this, square root of 24x squared all over 6x squared. Well, 24 divided by 6 is 4. X squared divided by x squared, those are gone. What is the square root of 4? The square root of 4 is 2. That's your lesson for today. We'll see you tomorrow, and we'll work on some more of these.